Dear students, welcome to a new topic of our second lesson in electrostatic field and potential. Today we will study the electrostatic potential energy, or very precisely electrostatic potential energy of system of charges. So here we are considering system of charges because we need to consider more than one charge. Okay, let me write some additional point which we have already discussed. First one is the potential. Next one is the potential difference. So these two topics are important for the discussion of the present topic. The present topic, as I told you, the potential energy. I hope I do not want to explain it again. The potential and potential difference. Very simply, I will tell you, potential is the energy required or the work needed to be done to bring a positive charge from infinity to a particular point, and potential difference is the energy required or work done to bring a positive charge from one point to another point. Now, what is potential energy? Potential energy comes from the state of configuration of charges. Since you already studied, potential is a conservative force, so it does not depend on the path. So we will discuss it later. Let me go into our picture. Here one boy is standing in space, as you can see. Let me draw one Cartesian coordinate system also, that is x-axis and y-axis. Just I am omitting z-axis just for the sake of explanation. I am just omitting. Now the boy is standing in a point. That point I am going to mark it as a P. So what is P? P is the location of the boy. And let me tell you one thing. The boy is charged with some positive charges. For the sake of explanation, you can take that the boy has only a single charge. So definitely what will be the potential of that particular boy in that field? Field means in the space. So potential due to point charge you will be writing. That will be the potential due to that boy. Okay, so I am writing potential V. Potential V is equal to 1 by 4 pi epsilon 0 Q divided by R is the potential due to point charge. Here I am writing Q divided by R1P I can write, or R1 I can write, or R2 I can write. Anyway, R is simply a distance from a particular location to the present location. So for the convenience of explanation, you can take this distance R based on your configuration. Okay. For example, if I draw a line from a particular location to the present location, so I can mark the distance as R1P. So I will be replacing that R with R1P in the above equation. So final equation will be looking like this. Now come to the second picture. Here you can see two boys. Suppose the first boy is you and the second boy may be of your friend. And as you know, if you consider the potential of the first boy, that is the potential, your potential, then V is equal to 1 by 4 pi epsilon 0 Q1 divided by R1P will be the potential of the green colored shirt boy, that is your potential. Okay, so I am writing the potential once again. V is equal to 1 by 4 pi epsilon 0 Q1 divided by R1P. Nothing new here. It is only the previous equation. Okay. Now the right side boy, he is your friend and he will have a charge of Q2 and you will have a charge Q1. So your potential is V1, I am writing, and he is coming from some other distance with a Q2 charge. So if he comes from another location to your location, of course both of you will be interacting. So what will be the work done to bring your friend towards your region? That is, work done to bring Q2 will be your potential into his charge. Okay, that is, work is equal to V into Q2. What is V? V is your potential and Q2 is his charge. So W is equal to 1 by 4 pi epsilon 0 Q1 divided by R1. You just wait it. In the previous equation I have written R1P. R1P is nothing. It is a distance from a particular location to a location in space where you were standing. Okay. Now where are you standing? Relative to your friend position, you can tell the distance R1P as R12. So no need to worry about distance. Just it is a mentioning that this R12 is a distance in connection with you and your friend. That's all. So final equation will be W is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. In previous year, you have already studied potential energy is the work done, or work done can be taken as the potential energy in Newtonian mechanics. So the electrostatic potential energy U is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. See, we have a beautiful equation. Now, as I told you that you are friends, so definitely you will be interacting with each other. So among friends, what kind of interaction will be there? An attractive interaction. Okay, attraction will be there. Attraction. Now, when you come into the world of physics, for being attracted, what kind of charges should be there? It should be positive and negative. Definitely, you know it. So if I take the product of two charges, that is Q1 and Q2, that means plus and minus, then definitely its result will be less than 0. Less than 0. Since one charge will be negative in nature. So definitely my equation will be negative in nature. So W is equal to minus. So I will explain you why this minus, importance of minus comes here. As I told you, both of you are friends. So definitely you may be attracting. So I need to give an opposite force to separate you. So the potential energy is negative. Negative in nature. Negative. So once again I am writing the product of two charges Q1 and Q2, Q1 into Q2 less than 0. So work is negative. So definitely the potential energy U will be also negative. Now come to the third picture. Here you can see these two boys are fighting each other. Definitely they will be of the same charges in the world of physics. Okay, because they are enemies. So Q1 and Q2, if I consider as a charges, then among enemies, what kind of force will be there? Definitely repulsive force. That is why I have taken negative, negative and positive, positive. So repulsion. So if I take repulsive force, work will be positive. What is work will be positive? It is very simple. Both will repel each other. So I need to give a positive work to meet them together or to meet each other. So my work is positive among them. That is why here the potential energy also comes as the positive. Just a diagrammatic representation with the electric field. Here we have two positive charges. Definitely they will repel. So their electric field will be looking like this. That is, they will not meet each other. They will be definitely repelling each other. Now just come to the fourth picture. Here you can see you and your friend are interacting each other, and a third party is standing near to you. So definitely we have three people, so three charges. So let me write the topic, the potential energy of a system of three charges. Three charges. So here, as I told you, you and your friend are talking each other. Your third friend is just standing near to you, and actually he is scared of both of you, and he has not taken the decision still whether he want to come or not. Anyway, come to the world of physics. Here we have a charge Q1, charge Q2, and a Q3, the third charge. So how can you correlate this example with the charges Q1, Q2 and Q3? Let your charge is Q1, your nearest neighbor friend, his charge is Q2, and your furthest friend, his charge is Q3. So what will be the potential of you and your nearest friend? That I have already derived it. That is the potential due to Q1 and Q2. We have derived it already, which is U is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. So the third friend is trying to come to your field where you have already has a potential. So I am just rewriting the potential. U is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. What is this? This is the potential between you and your nearest friend. So the third friend is trying to come to your field with his charge Q3 and Q1 your charge, Q2 your nearest friend charge. So definitely Q3 will interact with the potential produced by both of you, that is Q1 and Q2. Now let me write the individual potentials of you and your nearest friends, that is potential due to Q1 and potential due to Q2. I am writing separately, that is 1 by 4 pi epsilon 0 Q1 divided by R. R is a distance. For simplicity I am taking R1P. Why R1P? Because you have already came from some point, and I hope you remember our first diagram, and your friend R2P came from some other field. So with respect to you and your original location, I can write it as R1P. Now you just see the potential due to Q2. There I will change the distance as R2P. So 1 by 4 pi epsilon 0 Q2 divided by R2P. What is R2P? R2P is also a location of your friend, nearest friend, from somewhere he came already. Okay, so that is these two equations. Now I am writing the total potential. Total potential at the location. Okay, remember this is a potential due to you and your friend only. I am not considering the third friend. So the potential will be 1 by 4 pi epsilon 0, I am writing V12 is equal to, why V12? It is the potential between you and your nearest friend, which is equal to 1 by 4 pi epsilon 0 Q1 divided by Q1 divided by R1P plus Q2 divided by R2P. 1 by 4 pi epsilon 0 is a common, so I have taken outside. So this will be V12. So what is V12? Simply the potential between you and your nearest friend. Now the third charge Q3 is coming close to V12. So definitely work has to be done to move Q3 towards your place. Whenever a charge wants to come to a potential, we need to give a work. So work will be always potential into charge. We have already studied it. So I am writing here the work done to bring your third friend towards you will be that is now work done to bring Q3 to the place. I am writing the right side. W is equal to potential into charge. Charge means Q3 is your third friend charge and V is the potential V12. So I will be writing work W is equal to V12 into Q3. V12 is that potential which we have already derived. So 1 by 4 by epsilon 0 Q1 divided by R1P plus Q2 divided by R2P into Q3. That is 1 by 4 pi epsilon 0. Just distribute Q3 inside the bracket. So Q1 Q3 divided by R1P. I am trying to write R13 because Q1 multiplied with Q3 and Q2 Q3 divided by R23. So let it be an equation number 2, which is work done. Work done will be potential energy, you have already studied. Now what I am going to do, adding equation 1 and 2 for the total potential energy, because the first equation represents the potential energy between you and your friend. Now the third fellow also came. So the total potential energy of you and your friend and your third friend also I have to write it. So the sum of equation 1 and 2 will be the total potential energy that will be 1 plus 2, that is 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 plus that big equation. Where is that? This one, 1 by 4 pi epsilon 0. Okay, 1 by 4 pi epsilon 0 is common, plus Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. Just you take the distance in terms of Q1 Q2 or Q2 Q3 or Q3 Q2 like that. So this is the total potential energy of all the three system of charges. Now let me try to represent this in diagram. That is the three charges located at three vertices of a triangle Q1, Q2, Q3, etc. So R12 distance between 1 and 2, R23 distance between 2 and 3, and definitely R13 the distance between first and the third charge. I told you that the potential energy is a consequence of the configuration of charges. So these three charges are kept like this, that is why there is a potential energy. So by changing the configuration, the potential energy will also changes. So U is the characteristics of the configuration of charges. Remember, potential is a scalar quantity and the potential energy is a conservative in nature.